In this chapter, we will be studying polynomials and factoring. In this lesson, we will be exploring some basic applications of polynomials.
All right, now when it comes to applications of polynomials, to start off with, what we're going to do is something that's maybe a little forced, not very natural per se, but it's going to, we're going to kind of hit two topics here with one idea. We're going to do a little bit of geometry, really. But instead of using values, specific values, we're going to use algebraic expressions, polynomials here for the sides. So for example, we're going to talk about the area of a rectangle or a square here. We know that that's going to be length times width, but we're going to assume that the length and the width are going to be these algebraic expressions. Same thing for perimeter. Perimeter is going to be twice the length plus twice the width, right? Just going all the way around there. If you've got a cube, remember that the surface area of a cube is going to be 6 times the side length squared. Okay, and because remember there's 6 sides to the cube all the way around and then top and bottom. And then the volume would simply be length times width times height sort of thing. So you would multiply those 3 together. So now all we're going to do is we're going to answer questions based on these ideas, just with shapes where we're not given the exact value. We're given the values for the sides in terms of polynomials. So in this question we're told, determine and simplify an expression for the perimeter of the following. Okay, well the perimeter is simply going to be the sum of all 3 sides. Now that first side is 3x minus 6. The second side is x plus 14, and the third side, whoops, sorry, didn't put the plus sign in there. And the third side is 8x minus 4. Now, because I'm adding these all up, I can drop the parentheses without worrying about anything being altered here. It's only if there's subtraction in between that I got to worry about that. So I can drop the parentheses, get 3x minus 6 plus x plus 14 plus 8x minus 4. Now, x is my variable. I don't know what it is, but I've got 3 of them here, 1 of them here, so 4 plus 8x. Okay, so my perimeter is going to have 12x in it. And then over here I've got negative 6 plus 14. Okay, well negative 6 plus 14 is going to be 8. And then minus 4, that's going to be positive 4. So my perimeter, a simplified expression for the perimeter, would be 12x plus 4. Now in this question we're being asked to find a simplified expression for the area and the perimeter for each diagram. We got a couple of them here. So here's a square. I can tell because of those little marks there. So I know that the perimeter is going to be 4 times that side length. So 4 times x plus 3. And in this case, I can just distribute that through. We've already talked about how to do that. So that's a monomial by a binomial. So it'll be 4x plus, for a second there I wanted to put a different number, but 4x plus 12. And there's my perimeter. Now my area is going to be x plus 3, that's the side, squared. Now remember, I can't distribute that square to both of those terms because this is a binomial. It's not a monomial, it's a binomial. So the rule is a little bit different here. I got to make this x plus 3 multiplied by x plus 3. And when I distribute that through, I will get x squared plus 3x. That's that first term distributed to both of the terms in the second expression. And then I'm going to distribute the 3 to both those terms, so plus 3x plus 9. And then I've got 2 terms that are in terms of just x, and so there are 3 of them here, 3 of them here. There are 6x total plus 9. So there's the expression for my area, x squared plus 6x plus 9. Okay, moving right along. Let's take a look at this guy right here. Oh, this is a little bit more complicated. Got this little L shape here. Now, we got to be a little bit more creative here as we do this. We got to bear in mind that the implication here is that all of these are right angles. Okay, now there are a couple things that you can do here to get the perimeter. Okay, I mean I know that this side plus this side have to be the same as 2x minus 1, and I know that this side right here and this side together have to add up to 3x plus 4. Now, however, so there's a little bit of a shortcut you could take here, but just because we want to practice working with polynomials. I know that the entire length along this side must be 2x minus 1 and that this side right here is x. So this side right here has to be 2x minus 1 minus x. I'm going to lose that little x there. And so 2x minus 1 minus x is simply going to be x minus 1. That's the length of this side, x minus 1. This side right here is going to be 3x plus 4. And then I'm going to lose this x right here, so minus x. And that's going to give me 2x plus 4. Okay, now I've got little expressions for every side here. So the perimeter is going to be, okay, 3x plus 4 plus x plus 2x plus 4 plus x minus 1. Whoops, I'm going off the screen here. Plus x plus 2x minus 1. Got a lot going on there. Okay, but what I've done here is I've simply added the length of every side. Now, I'm going to drop the parentheses, but I'm actually going to do this pretty quick here because I'm going to lose space here in a second. So I've got 3 x's here, 1 x there. That's 4 x's plus another 2, that's 6 x's, plus another one, 7x, plus x is 8x, plus 2x is 10x total. Now I'm going to look at my constants from every term here. I've got 4 plus 4 is 8. Minus 1 is 7, minus 1 is 6. So my perimeter will be 10x plus 6. Now, my area, a little bit more complicated. Now, I can do this a couple of different ways though. Okay? I mean, I really can. I could split this up here because I've got length and width of that big square, and then I've got length and width of this little square, and I could add those up. I could also find the area of the largest square and then subtract this little one right inside here. I think what I'll do is what I suggested first off though, because way back when you would have done these sorts of questions back in like junior high, elementary or whatever, you probably would have done it like that. You'd have broken it up like this. So my area here will be 3x plus 4, length times width, and that's going to be for this section right here. This triangle, this triangle, that rectangle. Plus, I'll grab the area of this one, which is going to be x minus 1 times x. Remember, this 2x minus 1 is the whole side over both of those shapes there. So this will be x minus 1 multiplied by x. Now in this case, I'm still distributing, but I'm going to do it backwards here. So this will be 3x squared plus 4x. Again, distribute backwards. X squared minus x. And now, I don't know what x is, but I know that x squared will be different than x. I've got 3x squareds here and an additional one here, that's 4x squared. I've got 4x's here and I take one away here, so it's going to be plus 3x. And so there's my area, 4x squared plus 3x. Now in this question we're being asked to find the area of the shaded region, and I hope you can read those dimensions there. But what we're going to do for this one is we're going to figure out the area of the entire large rectangle here. Now that's length times width, so that will be 3x plus 2 multiplied by x minus 4. And then I'm going to just erase that rectangle in the middle there. So I'm going to subtract the area of this one, and that's going to be 2x, its width, multiplied by its length, x plus 1. Okay, so here's the expression here that I'm going to use. Now I just got to expand it and simplify it. Now I'm going to put this in brackets here because we're going to subtract these two terms, but I got to figure out what this term is first. So I'll multiply that through. I'm going to distribute both terms here to both terms here. So 3x times x, 3x squared, minus 12x, plus 2x, minus 8. And then I'll do the same thing here. I'm just going to distribute the 2x to both of those terms. So 2x squared plus 2x. Okay, I've got two terms that are considered like in here. Negative 12 plus 2, so it's going to be negative 10x minus 8. And over here I didn't, so it was just 2x squared plus 2x. Now, I've simplified what's inside both the parentheses there. Now what I'm going to do is I'm going to drop the parentheses. Because there's subtraction here, I'm going to distribute that negative through. So 3x squared minus 10x minus 8 minus 2x squared minus 2x. I don't know what x is, but I know that x squared is different than x. So I've got 3x squared here, negative 2x squared, that's just a single x squared. Negative 10x minus 2x together is negative 12x. And I've only got one term that's a constant, the negative 8. And so right here, we know that the area of that shaded region there's going to be x squared minus 12x minus 8. Now, By the way, what this means here is no matter what value of x I choose to fit into these expressions, this will always give me the area. Okay, so if you thought that x should have been 10, which made this 32 by 6, made this 11 by 20x, which in that particular case doesn't make any sense. But anyway, it gives you an idea here. When the numbers work consistently here, that's what that's going to look like. You have to choose a smaller number for x, obviously, for that to make any sense. But anyway, there you go. All right, now to do this question here, let me read through what's going on here. It says the bottom of a pizza delivery box is made from a square piece of cardboard which has sides of 38 centimeters. An equal square is cut off from each corner and the box is formed by folding up the sides, or folding the sides up. Write an algebraic expression for the area of the bottom of the box and the volume of the box after the sides are folded up. Okay, well, let's just take a look at this. So I know it's 38 centimeters all the way across. But this is x centimeters, and I'm going to fold that up. So that's going to stand up straight right up here. So I'm going to lose, in terms of the length of that square, I'm going to lose that length. But I'm also going to lose this length right here, this x right here. I'm going to fold those both up so that those are sticking straight up. It's going to look, if I could just help you out here, it's going to be something like this. So let's say, let's say that this is the bottom of that box here. I'm going to fold up a side that's x, fold up a side that's x. So now this length right here, which was 38, I'm losing an x, I'm losing x, I'm losing two x's there. So the length of this side is going to be 38 minus two x's. And actually, so will this length right here. That distance right there will be 38 minus two x's. Okay, now area is length times width. So it's going to be 38 minus 2x multiplied by 38 minus 2x. All right, now 38 squared, because I got to multiply that through here. Now I don't have a calculator handy, so I'm just going to run and quickly do this over here. That'll be 64, 64, 24, 30, 0, 24, 29, 11, 4, 4, 4. Wow, that was an awesome number. 1,444. Okay. 38 times negative 2 is going to be, well, 35 times 2 would be 70. So I'm just going to be 76. So minus 76x, minus 76x, and then negative 2x multiplied by negative 2x will be positive 4x squared. 4x squared, negative 76 minus 76 is going to be, what is that, 152? Negative 152x plus 1,444. I hope I got that right. 64, 24, 6. Yeah, sort of looks right there. I hope so. Anyway, there's my expression for my area. Now, I'm going to move over to my volume. Now when I flip this up here, bear in mind that this expression right here represents the base of that box, the area of the base, and then we've already established that the height of the box is going to be x. When I fold those sides up, if this distance right here is x, and I fold that up, then the height of the box is now x. So now the area is going to be length times width times height. Well, okay, that's going to be 38 minus 2x multiplied by 38 minus 2x. There's my length times my width, and there's my height, x. Now, I already know what that is because I just found the area. 4x squared minus, whoops, sorry, forgot the 2, minus 152x plus 1,444. And I'll multiply that all by x. So what I'm going to do now is just distribute that x backwards here to get 4x cubed minus 152x squared plus 1,444x. And there's the expression for my volume.